So the question that is available to you here is, it says if the directional derivative of the function z is equal to y square e to the power 2x at the point 2 comma minus 1 along the unit vector b, which is given to be alpha I cap plus beta j cap, this is 0, then the modulus of alpha plus beta is equal to which among these 4? So let's see for the solution. For the solution, what we are to do? We are to first calculate the directional derivative of this function at the given point along the direction of this unit vector. So that means whenever you are required to calculate the directional derivative, so you should remember that you require 3 things. Firstly, the given function. Second thing that is required here is the given point where you wanted to calculate the derivative, given point. And third thing that is required is the direction. So the direction is given by unit vector. So here all the 3 things they are given to you. The function is given to be z is equal to y square e to the power 2x. Point is given to be 2 comma minus 1, and direction here is given to be the unit vector b vector, which is alpha I cap plus beta j cap. So this is the unit vector. So if this is the unit vector, so that means the magnitude of alpha and the magnitude of beta, that both are equal to 1, right? So they are asking you what is the value of magnitude of a plus b, right? So this thing, if you now you would say that this magnitude of alpha plus beta, this is equal to magnitude of alpha plus magnitude of beta. So this thing is not true. So you cannot simply add the magnitude of these vectors to obtain the given vector. So for that we have to follow the proper procedure. That means first we have to calculate the directional derivative. So what is the definition for directional derivative? Suppose I am calling this by dd. So the definition of directional derivative dd, that is given by, suppose so our function here is z, right? So firstly we'll calculate the gradient of this function z at the point p, and then we will take the dot product of this gradient with this unit vector. So this is the definition for calculating the directional derivative. Now first of all, let us calculate this. So the definition for this del operator, that is del by del x I cap plus del by del y j cap plus del by del z k cap, and the vector function z, that is given to be y square e to the power 2x, right? And we are calculating this at the point 2 comma minus 1. 2 comma minus 1, and actually here we are given this to be in the 2D plane, so it is also not required that we take this component del by del z k cap. Even if you take, there is no difference. So let's take it and solve it. So we have dot b vector. B vector is given to be alpha I cap plus beta j cap, right? Now if this is a unit vector, if b is unit vector, so that means you can you know that the magnitude of this unit vector should be equal to 1. So what is the magnitude of this vector? It is alpha square plus beta square square root. So this is equal to 1. So this is our equation 1, which give you the relationship between alpha and beta, because in the question they have asked about the term which involves alpha and beta. So in order to determine this, we are to determine what is alpha and what is beta. So here we got one equation. Because we have two unknowns, so we also need one more equation. So one more equation is given by when you solve this quantity. So when you solve this, so what do you have? You firstly perform the partial derivatives. So it would be del by del x of y square e to the power 2x into I cap plus del by del y of y square e to the power 2x j cap, and the component for z would be 0, because when you perform the partial derivative of this function with respect to z, that would simply be 0. So we have the point 2 minus 1, and we have to take the dot with the vector alpha I cap plus beta j cap, right? So let's solve this. So firstly, we'll perform the partial derivatives here. Firstly, when you perform it with respect to x, so it would be 2y square e to the power 2x, I cap would be as such, and then when you perform it with respect to y, it would be 2y e to the power 2x j cap. And then you will substitute the value of this point into the given vector. Okay, so when you substitute the given vector here, so it would be in place of y we will write -1, in place of x we will write 2. So we have 2 into -1 e to the power 2 into 2 j cap. You have to take the dot of this vector with alpha I cap plus beta j cap. And in the question, notice that this derivative along this vector is given to be 0. So that means the right hand side of this quantity, this is the directional derivative, its value is equal to 0. This is given to you in the question. Okay, so let us solve this. So we have 2 e to the power 4 I cap minus 2 e to the power 4 j cap, and you have to take the dot product with alpha I cap plus beta j cap. So when you take the dot product, you will obtain 2 e to the power 4 alpha minus 2 e to the power 4 beta. So this quantity is equal to 0. Now from here, you can take e to the power 2 e to the power 4 common. So you have alpha minus beta is equal to 0. Now this quantity cannot be 0. Therefore, you have alpha minus beta equal to 0. So that means alpha is equal to beta. So from this equation, you obtain the value of alpha and beta to be equal. So we can substitute this value in equation number 1. So what is your equation 1? Equation 1 gives you the magnitude of vector b as equal to unity. So this is your equation. So you have alpha square plus beta square. So you have alpha square plus beta square, square root is equal to 1, or you could write this to be alpha square plus beta square is equal to 1. Now both alpha and beta, they are equal using equation 2. Therefore, we have 2 alpha square is equal to 1, or you obtain the value of alpha is equal to plus minus 1 by square root 2. So, and this is also the value for beta. Why? Because alpha and beta, they are equal. So we also obtain the value of beta as 1 by plus minus 1 by square root 2. Now in the question they are asking, determine what is this quantity, magnitude of alpha plus beta. So now you have the value of this. So let's take the positive quantity. So it would be plus 1 by 1 by square root 2, and then it would also be plus 1 by square root 2. So it would be 2 by square root 2 modulus. So it would be square root 2, right? And if you take the value as the negative value, so that means you will have minus 1 by square root 2, and beta is also equal to alpha, so it would also be minus 1 by 2. So you will have minus 2 upon square root 2. So this quantity would be minus square root 2, and when you take the modulus value, positive value, so you obtain this as the final answer. So square root 2 is the answer for this particular question over here. So that means our option C here is the correct option.